So hello friends and welcome back to my channel GATEquestionsECE, and I am back with the next question on random variable, and the question code is 106. If random variable z, x1 and x2 are related by z is equal to maximum among x1, x2, then which of the following statement is true for the CDF of z? We have to tell which of the following is true for the CDF of z. Basically, he is asking what is the relation between the CDF of z and joint CDF or marginal CDF of x1 and x2. So let's see the solution of this problem. I have already discussed this question in question number 102, part 1 and part 2. In that question, there was a numerical that was based on this question. So now, once again, we will see what is the relation between the CDF of z and the CDF of x1 and x2 or joint CDF of x1 and x2. So firstly we will see what is the CDF of or joint CDF of x1 and x2. We know that the CDF of x1 and x2 is represented by this mathematical expression. So this is equal to probability capital X1 is less than equal to small x1 and for intersection capital X2 is less than equal to small x2. We can see in this diagram, in the first diagram we can see on this axis, this point is, on this point x1 is small x1. So this line that is passing through this point, this line here, this line is capital X1 is equal to small x1 line. Similarly, on x2 axis, this point here is small x2. So this line that is passing through this point here, this line is capital X is equal to small x2. And these both lines will intersect at this point small x1 comma small x2. So the probability that x1 is less than equal to x1 and x2 is less than equal to x2 is the probability that capital X1 and x2 lies in this region, which includes this boundary of x1 is equal to small x1 and x2 is equal to small x2. This boundary, this inverted L-shaped boundary, as well as the region that is lying to the left of this inverted L-shaped boundary. So that is the definition of joint CDF of x1 and x2. So now we will see what is the CDF of z, where z is maximum x1 comma x2. Suppose capital Z has a sample value small z, then the conclusion that we draw from part 1 video and part 2 video of question number 102, that this is an inverted L-shaped, like this. In this diagram, this is an inverted L-shaped boundary. Similar to this boundary here, we can draw a boundary here. It is an inverted L-shaped boundary with corner at z comma z. So you can observe here that if you take any point on this inverted L-shaped boundary, for that point maximum x1 comma x2 will be equal to small z. For example, if you take a point here, you can write this point as x1 comma x2, and on this section x2 is small z. You can observe here that as we move from this point here, x1 is z, and as you move to the left on this line, x1 will keep on decreasing. So on this line, x1 has maximum value at this point, and as you move to the left, x1 will decrease below z. So on this line x1 is less than z. So maximum among x1 comma z will be z. So on this line maximum x1 comma x2 will be z. Similarly at this point which is z comma z, you can observe maximum x1 comma x2 will be z. Similarly you can take point anywhere on this section of the line. For example, if you take point here and you can write this point as z, because here x1 is z and x2 you write as x2. By the similar explanation that we use here, we can write that anywhere here x2 is less than z. So maximum among x1 and x2 here is z. So for all the points that are lying on this line, maximum x1 comma x2 will be equal to z. So by this explanation you can note that everywhere on this boundary maximum x1 comma x2 will be equal to z. And you can similarly, by taking any point and in this red lined region, you can observe that maximum x1 comma x2 will be less than z. For all the points that are lying in this red lined region, maximum x1 comma x2 is less than z. And for all the points that are lying in this non-shaded region, you can observe that maximum x1 comma x2 is greater than z. So according to the definition of CDF of z, we can write it as f capital Z for sample value small z. So it is equal to probability that capital Z is less than equal to small z. So we can write this as probability maximum x1 comma x2 is less than equal to small z. So you can observe here that this probability includes maximum x1 comma x2 is equal to z as well as less than z. In this diagram we observed that maximum x1 comma x2 is equal to z for this inverted L-shaped boundary, and it is strictly less than z in this region. So this probability is nothing but the probability that x1 x2 is jointly distributed in this region that includes this less than z and equal to z region. So, and also from this definition of joint distribution of x1 and x2, we observe that it is the probability that x1 and x2 lies jointly in this region, which includes this red line region as well as this boundary. You can observe here that these two regions are similar, except here x1 and x2 are equal in this case, and they are equal to small z. So from the definition of joint CDF of x1 and x2, you can write the probability of x1 and x2 lie in this region will be equal to capital F x1 comma x2 z comma z. By just comparing these two, you can write this. And also this probability is the CDF of z. So we can write that capital Fz small z will be equal to the joint probability of x1 and x2 provided their sample values are z comma z. So that is the relation between the CDF of z and the joint distribution of x1 and x2. So the correct answer is option 1. So option 1 is the correct answer here. So you can remember this final result as it helps in solving many numericals. Also note that we haven't assumed here that x1 and x2 are independent. So this result is valid even if x1 and x2 are dependent. And moreover, if x1 and x2 are independent, then the above result will reduce to capital Fz will be equal to the product of marginal CDFs into f x2 z into the product of marginal CDF will be equal to the CDF of z. Also observe that this result is valid for both discrete and continuous type random variables. So now we have solved it for two random variables x1 and x2. We can generalize this for n random variables. So let's see now the result for n random variables also. That is equal to maximum x1 comma x2 comma x3 up to xn. We are given n random variables. For that, the relation between the CDF of z and the joint CDF of x1, x2, x3 up to xn will be f capital Z small z will be related to the joint CDF of all the random variables by this relation. So this is the relation for CDF of Z and joint CDF of all the random variables. So this is also true for dependent cases where x1, x2, x3 all of them or at least some of them are dependent, and if they are independent then we can write them as the product of their marginal CDFs. So this is the result for independent. All the random variables are mutually independent. Also note that these results are valid for both discrete and continuous random variables. So I hope you can directly use these results for solving many numericals. So I hope you have learned some new concepts. To learn more such concepts and tricks in solving the random variable problems, please do subscribe to my channel and please press that like button below this video. So thank you for watching this video.